So today I want to solve a problem that's a little bit different because it's from a 1995 paper in IB Mathematics Higher Level. But it's a related rates question, and it says that a parallelogram has sides of length 8 centimeters and 15 centimeters, and the angle theta at one of the vertices is decreasing at the rate of pi over 60 radians per minute. What is the rate at which the area of the parallelogram is changing when theta equals pi over 6? So let's just go ahead and draw this parallelogram here. Like so. Okay. Oh. That's bad drawing, but it's fine. So we'll take this one as 8, this one is 15. And this is going to be our angle theta here. And we'll say d theta by dt is going to be equal to minus pi over 60, because decreasing at pi over 60 radians per minute. And we want to find the area of the parallelogram. So we know that the area of the parallelogram is going to be equal to, well, the area of this triangle plus the area of this triangle. So we know this side is 15, this side is 8, and this is gonna half the area. So the area of this triangle right here is going to be 1 by 2 8 AB sine theta. And if we take two of these triangle areas, we'll get the full area of the parallelogram, which is equal to 2 times, and the half will cancel out. So the area of the parallelogram is going to be AB sine theta. Now, from here, we know that A and B is 15 and 8, and 15 times 8, doing it in your head, 120. So A is going to be 120 sine theta. So if we look at this here, we have d theta dt, and we want to find the rate at which the area of the parallelogram is changing. So that's going to be dA by dt. And dA by dt, if we do some quick rearranging, we get it's going to be d theta by dt times d theta, or dA by d theta. And this is because while the differential is not really a fraction, in this case we can treat it as one, d theta and d theta cancel out, and this one will go here. So it becomes dA by dt. So we get dA by d theta is going to be equal to 120 cosine theta. And we also have d theta by dt, so dA by dt is going to be minus pi over 60 times 120 cosine theta. And now this we can simplify, and we get minus pi, or 2 pi cosine theta. And they want us to find it when it's theta equals pi over 6. So we get minus 2 pi cosine pi over 6, or minus 2 pi times root 3 over 2. 2's cancel, and we get minus pi root 3. Let me move this here. It's going to be centimeters squared per minute. And that's our solution to the problem.